In this video, we're going to look at three very important definitions about bounded sets. In all of our definitions, we are going to let S be a non-empty point set. Now, what that means is that S is a subset of the real numbers, and S is known to not be the empty set. In our first definition, we say that S is bounded above by the number x if and only if x is bigger than or equal to little s for all little s belonging to set S. We can draw a picture of what this definition means as follows. There's my number line, here is x, and if we say that S is bounded above by x, that means all of the elements of S live to the left of x. So all of S lies here. Now, there's a couple of other things that I want to point out. In this kind of context, we also call x an upper bound for the set S. And then there's another observation. If x is an upper bound for set S, and I have a number a that is at least as big as x, then a lives here, and clearly a is bigger than everything inside S, so we can say that a is also an upper bound for set S. So upper bounds are not unique. Well, there's nothing special about bounding stuff above, so let's look at a second definition. If we can find a y inside the real numbers such that y is less than or equal to little s for all little s inside set S, then we say that, first of all, y is a lower bound for set S, and we also say that S is bounded below. Let me highlight that as well. And we have a similar kind of picture that we had before. If this is my number line and I put y on this number line, saying that y is a lower bound is going to mean that all of the elements of set S have to live out here. So all of S lies here. And clearly, if I happen to know that y is a lower bound, so if I know that y is a lower bound for S, and I know that b is less than or equal to y, then b is here, and clearly b is also less than or equal to all of the s's inside S, so I can then say b is also a lower bound for set S. So lower bounds are also not unique. Well, our third definition is something that takes into account what do we want to call sets that are both bounded above and bounded below. And so our third definition looks like this. we say S is a bounded set if and only if S is both bounded above and bounded below. So I want to think about what that really means. Here's my number line, and let's kind of sketch in some stuff that is supposed to represent my set S. So this is supposed to be S is a bounded set. And what that means is I have to have some upper bound and I have to have some lower bound. I'm going to call A the lower bound for S. And we're going to make B into the upper bound for S. And now if I think about the closed interval going from A to B, then what I notice is that S is a bounded set if and only if there exists a closed interval namely the interval running from A to B, such that S is a subset of that closed interval. And so this is another alternative way about thinking about bounded sets. I want to kind of carry this idea on just a little bit further. So I also want to make this note. This time I'm going to draw a couple of number lines with zeros on them. So here's my first number line, here's my second number line. And what I want to do is I want to put in a 0 on both of these. And now I'm going to kind of sketch two sorts of bounded sets. So let's see, in my first one, my bounded set's going to go something like this. And in my second one, the bounded set's going to go something like this. Now, what I want to notice in both of these is that I have the following idea. Sure, I can find the interval from A to B there, but if I look at minus B would come down here. And in this first set, what I want to notice is that in this set S, every little s has absolute value being less than or equal to b. So in other words, and this is true for all little s inside set S. Now in this particular one, I'm going to be thinking about my lower bound here being minus b, and I can look at positive b here, and in this set as well. The absolute value of little s is going to be less than or equal to b. And that's going to be true for all s inside set S. And both of these are true because what we have is that minus b is less than or equal to little s, and little s is less than or equal to positive b for all s inside my bounded set. So the upshot is that we have another way about thinking about bounded sets. We can also say that S is bounded if and only if there exists a positive real number, so B is positive, such that S is inside the closed interval minus B to positive B, or in other words, the absolute value of little s is less than or equal to positive b for all elements inside my set. So we now have several different ways about thinking about what a bounded set means. In the next video, we're going to look at a special case of bounds, and we're going to define what are called the supremum and the infimum of sets.